let's look at the second half of 4-1. It's our word problems. So this is our day 2. It is Halloween. See, we'll have a little bit of fun.
I'm here.
Ooh and ah.
Thank you, Miss Marie.
No, I'm not giving you candy too.
No.
You should.
Okay, I'm a math teacher. I can't afford all this. Stop right now. All right, so we're going to use arc length in various word problems. The very last word problem that I do is going to seem complicated because I'm going to teach you how we came up with a conversion, and then you can use that conversion from here on out. But we're going to go through the process of finding the conversion because somehow somebody had to find a conversion in order to use it. We're going to use 2 different arc length formulas. This one versus this one. This is if our central angle is in degree measure, and this one is if our central angle is in radian measure. So let's kind of explore how they came about. So, if I go back to geometry and I want to look at the arc length that you learned how to find in geometry. So remember that arc length is part of the circumference of a circle. And so if you look at the circle from way on the front, this is an arc length here, S, and it's part of the whole circumference of that circle. And the central angle is what intercepts that arc. And so we need that central angle, we need the radius, and we can find the arc length. The arc length that we're looking for is the portion that that central angle is of the entire circle. How many degrees are in the entire circle? 360. And so if I find the portion or the fraction that that central angle is of the whole circle, then that arc length ought to be the same fraction of the entire circumference. So, in geometry, you learn how to find arc length by taking the fraction of your central angle, so we're going to let theta be our central angle, divided by 360 degrees. So that gave you your fraction that central angle was of the whole circle, and then you multiply that to 2 pi r over 1. That's your circumference. Well, why are they using this then? Because this is when our arc length is in degrees. Didn't they just cancel out 2 with the 360 and we got 180 degrees? So we end up with pi r theta in the numerator and 180 times 1 in the denominator. So that's where that one came from. This is a more simple formula than that one. And I'll give you that formula, although you ought to be able to construct it yourself. So that's when your theta is in degrees. So if I want to convert degrees to radian, what do? What would I do to this formula to convert the degrees to radians? I have my conversion for degrees to radians are these ones right here. Remember those? Yeah. So I currently want to get rid of my degrees and I want to go to radians. So my pi is here, is it not? My 180 is here. And that's going to get rid of my degrees. Whatever I want to get rid of, it's got to be diagonal. So won't the 180 and the pi cancel out? So if I want to get rid of degrees, the degrees has to be diagonal. So those are going to cancel out, but so will the pi. Aren't I left with just r theta? Yes. So when I convert from degrees over to radian measure, that's how we got the r theta. We tend to like to use this formula over this one because isn't it the most simple out of the three? So if you can take your central angle and convert it to its radian measure, that's an easier formula to use. So you'll see us doing that a lot. But if I'm given my central angle in degrees, I'll tend to start with that one. If I'm given my central angle in radians, I tend to start with that one. So let's look at two somewhat simple problems compared to the rest of them. So we're going to find the perimeter of a 60-inch slice of a large pizza. Pizza slice looks like this. Well, the 60 degrees, the slice, this is your angle, isn't that your angle? No, I said 60-degree slice of a large pizza is a 7-inch radius pizza. A 60-inch radius pizza would be quite a large pizza. There is a place in California, in San Diego, where they literally have pizzas this huge. It covers the entire table. So isn't that what your slice of pizza, the shape of it looks like? And then you'll have, oh, I like pepperoni.
And bacon, add bacon.
So there's my pepperoni slices.
Good job, Miss Mary.
So
You're an artist.
what they're saying is the radius of my pizza is 7 inches. So the straight edges of my slices are 7 inches. What I don't know is this right here, which I'm going to term as S. Because that's the curve, but I'm going to term that as S. That's a real scraggly S. My 60 inches is in here. Of 6 inches. 60 degrees is in there. That's what my central angle is. So my theta is 60 degrees. My radius is 7. My theta is in degrees, so which of the two formulas above are we going to use? The left or the right one?
Left.
The left one. So, S, because I need to find S, S is equal to pi times my radius times my central angle, all divided by 180 degrees. So my radius is 7 inches. My theta is 60 degrees. Don't my degrees cancel? And doesn't 60 cancel into 180? 3 times. So technically my exact measurement for S is 7 times pi, so 7 pi, somebody's phone is on, over 3 inches. And that is approximately, let's find that out on our calculator. So 7 times pi divided by 3. So it's approximately 7.33 inches, right? So we get approximately 7.33 inches. Now let's find the whole perimeter. So my whole perimeter, I'm going to walk around it, is 7 plus 7, so 7 inches, plus 7 inches, plus my S, which we have determined is 7.33 inches, for a total of how much? 21.33 inches. Therefore, the perimeter of the pizza slice is about 21.33 inches. That is neat on I swear I turned it off.
It's an unknown number, you're good.
Next week? No, I'll bring you cupcakes.
Really?
But you have to steal them because technically I'm not allowed to bring cupcakes.
Miss Gertson could make one for you.
Oh, I can make my own cupcakes, thank you. Although Miss Pearson's cupcakes are delicious. Stop. You are driving the same thing. You have too much candy. Well, then don't eat it. All right, let's look at number 6. Let's look at number 6. The running lanes at the horizon track are 1 meter wide. The inside radius of lane 1 is 33 meters. And the inside radius of lane 2 is 34 meters. How much longer is lane 2 than lane 1 around one turn? I'm missing that part. One turn. Well, it'd be nice to know what they look like. And one turn, they're just talking about just the curved part of the track, not the straight part of the track. So we're talking about this part right here. So there's one lane, and here's the second lane. Now you've seen runners staggered, correct? So this is going to be lane 1 and lane 2. The reason why they're staggered is because the distance here is obviously shorter than the distance on the outside lane. Then they tell you that right here would be the radius, because isn't this a half circle?
Yes.
So right here is the radius, and they say the radius of lane 1, so that would be important. Radius of lane 1 is 33 meters. So from here to, we'll go to the middle right there, that should 33 meters. And then the radius of lane 2 is 34 meters, so it's 1 more meter. So the question is, how much longer is lane 2 than lane 1 around one turn? It's not 1 meter because we have a curved distance. It's not a straight distance. So I have to find that distance from here to here and the distance from here to here and subtract the two to find the difference. So that's arc length. In order to use arc length, I need to know a central angle. So step 1, let's see how this shows up. Oh, that'll work. So step 1, each central angle is what? What do you think the central angle is?
The radius.
I'm going from here all the way to here. 180 degrees. So I could use 180 degrees, but that would force me to use this formula over here for arc length, right? Yep. I'd rather use the radian measure because the formula is easier. So what's the radian measure of that central angle? What's the same as 180 degrees in radians? Or pi, right? So here's 180 degrees, isn't it equal to pi? So we're going to use pi. Is equal to pi. And it's imperative that you write down all the notes that I have up here. Because you're going to go home and go, where did you get pi from? I can't remember where pi came from. So you might want to write in here that it's a half a circle. Then step 2. So we now have our theta. And we have a radius, don't we? So we're going to use S equals R theta, and the reason for that is our central angle is in radians. If you use the 180 degrees, you'd have to use the other one. The difference in their lengths, because this is going to give us the length of each lane, so their difference is, so how do I find the difference in their lengths? I'm going to use pi theta and subtract that for each of those. So what's the radius for, which is the longer lane, 1 or 2? 2. So what's the radius for lane 2? 34. So I've got 34, and its theta is pi minus, what's the radius of lane 1? 33. Its central angle is also pi, and so that gives me 1 pi, doesn't it? Which is approximately equal to 3.14, and this is in mile or meters. So isn't the difference between them, between the lengths that the runners would be running, 3.14 meters? So that's why you see them staggered, so that when they start out, and their finish is staggered too, depending upon how long the run is. So it's always better to be in the interior lane, yes.
So when you do these formulas, it is always going to
In this case, it was a half a circle.
or whatever.
Yeah, if we were looking at the distance from like here to here, I would have had told you that theta is, pi over 4, let's say. And then you would have pi over 4. And they both would have that same theta because it's running through both of those, but their arc measures are going to be different. Juan, is that your question? Juan? Because we decided to put our central angle in terms of radians. So because you know how I got the central angle? So because I went from here to there, that was 180 degrees. could use 180 degrees. If your central angle was in degrees, then you would have had to use that formula right there, which is a more complicated formula. Because it's a more complicated formula, I'd rather use that one. So we decided to put our 180 degrees into radians, which pi is the equivalent measure of 180 degrees. If that makes sense. So you could use degrees, you're just going to use a more complicated formula. So, therefore, the difference between lane 1 and lane 2 is about 3.14 meters. So those are somewhat simpler problems compared to some that you can have today. We're going to look at a more complicated conversion problem. So that was just finding arc length. The next two are conversion problems. So are you ready for those? All right, so I'm going to zoom back out. So for number 7, we're going to look at angular speed. Mrs. Strang's SUV has wheels that are 36 inches in diameter. So it's not a radius, in diameter. They're huge. If the wheels are rotating at 630 RPMs, which are revolutions per minute, it's the number of revolutions in 1 minute, find the truck speed in miles per hour. So all we're doing is converting this 630 revolutions per minute into miles per hour. But the diameter of the wheels is going to make a difference. A smaller wheel revolves quicker than a larger wheel, doesn't it? If any of you have ever hiked I have a Jeep Wrangler, if any of you have ever raised your truck or your SUV or even your car, whatever it is, and put bigger wheels on it, is your speed accurate anymore on the speedometer? No. And you find that out the hard way sometimes by getting a ticket. And you're like, oh. Because a bigger tire can travel further than the smaller tire, right? So let's look to see what we have. So step 1, the radius, because I need radius, I don't need diameter. So what's the radius? It's 18 inches, right? And so, if you go back to our definition, doesn't 1 radian here, 1 radian, equal our radius? Okay? So if our radius is 18 inches, it stands to reason that 1 radian in this case is equal to 18 inches. We're going to need that. 1 radian in this case is equal to 18 inches. One radian, the radian is always equal. When the arc measure is equal to the radius, that is what 1 radian is. So in this case, if my radius is 18 inches, then 1 radian must be 18 inches. 1 radian represents that arc length. All right, so step 2. Let's start with our conversion. So we've got 630 revolutions, so revs, per 1 minute. Let's go with the easier conversion, minutes. We want to convert minutes to hours. Do you know how many minutes are in an hour? 60. So does 60 minutes go up top or on the bottom? I want it to be diagonal so that the minutes cancel out. So the 60 minutes goes up top, the 1 hour goes in the top. That way, my minutes cancel. So now I have what I'm looking for, hours in the bottom. So I'm done with the bottom. Now all I have to do is start to convert revolutions. 1 revolution. We have to come up with a conversion for 1 revolution. And bear in mind we have this conversion in radians. So 1 revolution is equal to how many radians? Well, 1 entire revolution around the circle, so let's go around our circle. So here's our circle. I go all the way around the circle. How many radians is 1 full revolution around a circle? There's no such thing as 4 on that circle. And that's not 7. It's not 6.
5.
It's not 5. Here's half of a revolution is pi. A whole revolution is 2 pi. Remember this part right here? That's the radian measure. I don't want to look at the decimal equivalency. I want to look at the exact radian measure, which is 2 pi. 1 full revolution around the circle is 2 pi in radians. So 1 revolution is equal to 2 pi. So that's another conversion that we're going to use here. So I can get rid of my revolutions. Yes. Not degrees. Because I like to use radians. It's easier on us, number-wise. You could do it in degrees. You have to do 360 degrees. So you could say 1 revolution equals 360 degrees, but then you have to deal with everything in terms of degrees. And that makes bigger numbers. Would you agree 360 is bigger than 2? So that's why I'm choosing the same degrees. You're more comfortable in degrees because the degrees make sense to you. Am I right? Well, I don't have any degrees here at all. Because I have a choice for, I want to get rid of revolutions. I've got to make revolutions into miles. So my nearest conversion for revolutions that I can think of is, okay, I'm going around in a circle. So 1 revolution around a circle is either 360 degrees or 2 pi when it comes to degrees versus radians. So I have to make a choice. I'm choosing the stick of radians. Okay? And so that's why I chose this one. I could have done 1 revolution is 360 and then just our numbers are there. So I'm going to use that one. So let's use this. I want to get rid of revolution. So the revolution goes up top or on the bottom? On the bottom, because I want it diagonal. So 1 revolution is exactly equivalent to 2 pi. And isn't that 2 pi in radians? There's a reason why I'm tacking that on right now. This right here is really 2 pi radians, because that's in radian measure versus degrees. And you'll see why we need that. This way, my revolutions cancel, and I now have radians per hour. Now I have to convert the radians. Yeah, I get rid of radians. Don't I? And I'm trying to get to miles. Don't I have a conversion here for radians to inches? That finally gets me into true measurements that we're comfortable with. So I'm now going to use this conversion. So next, I want to get rid of radians. So 1 radian, does it go on the top or the bottom? Bottom. So 1 radian is exactly equivalent in this case to 18 inches. Because that's our radius. So that means that my radians cancel. And now I have inches per hour. Do we have a direct conversion for inches to miles? There is one, but I don't know what it is because it's a big number, so I choose not to memorize it. But I can do inches to what? Feet. So how many inches are on 1 foot? There are 12. So do I want my 12 inches up top or on the bottom? On the bottom. So 12 inches is exactly equal to 1 foot. Now we're getting somewhere. So my inches cancel. And you do need to know this. What's your conversion for feet to miles? Yep. So times 5,280 feet is exactly equivalent to 1 mile. And so finally my feet cancel and I have reached my ultimate goal of miles per hour. So I can stop. Once I've converted the numerator units of measure and my denominator units of measure, I can stop and I can make out my handy dandy calculator and I can just go through the multiplication. So do the numerator separately from the denominator. So I know it's hard to read the red, but hopefully you put it on your paper. So we've got 630 times 60 times 2 pi, use the whole pi, times 18 times 1 times 1. And so that's what the numerator is. And then my denominator is 1, 1, 1, 1, 12. So divided by, in parentheses, 12 times 52. And those parentheses. Is that a reasonable speed? Because revolutions per minute is speed. We're converting it to miles per hour. Is that a reasonable speed? Depending on where we're at. But yeah, the car could be going 67.47 miles per hour. Now, we're going to talk about rounding. What? Oh, yeah, maybe. The cop would look at you and go, really? Let me whip out my math. I was actually going with revolutions per minute. I miscalculated my speed. Notice how everything that you were given was in whole units, no decimals. So technically, our significant digits here are whole units. And I will give you leeway on rounding unless I specifically say round a certain amount of places. So the nearest whole miles per hour is what? 67. So this is approximately equal to 67 miles per hour. So therefore, step 3, therefore, Mrs. Stratton's SUV is traveling somehow I don't think there's 12 in travel. About, I'm a math teacher, oh well, about 67 miles per hour. My mother would recall, she was an English teacher. So that's just a very long conversion. So there was some new things in there. You're perfectly capable of converting, normal metric to metric and American standard to American standard. So the new things that were in here were these two things right here. So that's the part you should be studying. How did we use those and why did we use them and how did we come up with them? So those are some new conversions to you. And once you had the conversions right there, then all you had to do is just use your calculator, multiply it out, and divide it. Done. The last problem's a bit hairy. It's a bit hairy because you've got to learn how to do the conversion. And then once you know what the conversion is, then you can use it and your work becomes significantly shorter. So you ready? Take a deep breath. In through the nose, out through the mouth. Don't you feel much more relaxed? All right, so we're going to convert nautical miles. I had the funniest thing happen last period. Lane. Anybody know Lane? You've seen what Lane's wearing today? So, complete in costume, Lane has a big bad wolf head on, and it's a pretty scary head, right? Does anybody know the conversion that 1 nautical mile equals to a regular mile? No, but close, but no. Apparently, Lane is listening to the pilots on the airplane as he's talking about, we're entering such and such a city, whatever. Well, he gets there and he starts talking like the pilot. You know how the pilots kind of go, he's sounding just like the pilot. And he goes, 1 nautical mile is equal to 1.15 stat miles. And so he even knew what they were called. So I was just laughing at him. So he actually learned something while flying on the airplane by listening to the pilot. So there is a conversion for nautical miles to what we call statute miles, which are our regular miles. When you are a sailor or a pilot, you tend to make your calculations in terms of nautical miles. So a nautical mile is specifically, you might want to write this down, a nautical mile is specifically the length of 1 minute. You might want to write this down, Ellie. 1 minute of the arc of the Earth's equator. equator. There we go. So we got the Earth's equator. So if you think about the Earth's equator, that is the great circle around our sphere of the Earth. If you cut it off at the equator, and you look at what's left over, that's the great circle of the Earth. And so we want 1 minute of the arc of the Earth's equator. So there are how many minutes in a degree? Because there's 360 degrees. So how many minutes are in 1 degree? Not six, well, there are 60 minutes in 1 degree. So then one minute is equal to how much of a degree? 1/60th. That's all we're looking at. So a nautical mile is very tiny, isn't it? It's 1/60th of a degree of the arc of that great circle. So we are going to come up with a conversion to the nautical mile. Once we come up with a conversion to the nautical mile, then you can use that conversion in your homework tonight when you do your math Excel. So your homework shouldn't be this long, but we're going to come up with how we found that conversion. So you ready?
Yep.
Please take detailed notes. I can't emphasize that enough. So, step 1. Well, let's read the problem. Jim Johnson, a pilot for Husky Airlines, frequently pilots flights from New York to Phoenix. A distance of, you're missing that, distance of 2,698 statute miles. So you'll hear me call them stat miles. That's just your normal miles that you and I think of all the time. But when you're a sailor or a pilot, you consider them as being different, which they are. Captain Johnson's calculations of flight time, however, are based on nautical miles. How many nautical miles is it from New York to Phoenix? Well, we know how many stat miles it is. If we had the conversion for stat miles to nautical miles, we could use that, just like we used conversions up here. But we don't, so we're going to come up with it. We're going to come up with that, Mr. Smarty Pants. So here we go. Step 1. Please number your steps. They'll get confusing. So one thing that you need to know in order to make this conversion at the Earth's equator, you need to know the radius of the Earth. Because to calculate arc length, which is what we need to find out what is 1 minute of the arc length, we need to know radius of the equator. So, the radius, and I will give this to you if you should need it. So the radius, there we go. So the radius of the Earth at the equator is approximately equal to 3,956 stat miles. That's something you need in order to do the problem. That's a given. And that obviously was not calculated by taking a measuring device. We use math to calculate that. We can't exactly get to the center of the Earth. All right, so step 2. Can we calculate the radius of the equator if we know the circumference of the equator? Yes, we can. And that's how we do it. All right, so step 2, we need to convert. So here's the starting of the conversion. So we're going to convert 1 minute. Ellie, come on, don't fall behind. 1 minute to radians. So 1 minute equals how many degrees? Because we have to start there. In order to convert to radians, because we like to use the radian formula better, I have to know how many degrees that 1 minute is. So that's 1/60th of a degree, right? So we have to convert 1/60th of a degree into radians. I want the degrees to cancel. The degrees technically is up there. It's not with a 60. So what do I want to multiply by? Do I want my 180 in the top or in the bottom? On the bottom, so I want the degrees to cancel. So I have 180 degrees down here over, and then pi is above. Now my degrees cancel, don't they? And nothing else does. So that is equal to pi divided by 60 times 180 is 10,800, and this is now in radians. That's what 1 degree equals in radians. Are we good with that? All right, so then we have our formula. So next, we're going to apply S equals R times theta. That's why we converted 1 minute to radians, and so we could use that formula. So don't we know our radius of the great circle? Isn't it this right here? Isn't it that our radius? And our theta is 1 minute, which we just converted to radians, so we could use that formula. So this is our central angle, 1 minute, which is pi over 10,800 radians. That's going to get us our arc length of 1 nautical mile. And so, here we go. You might want to write yourself a note that we are finding the distance of 1 minute of the equator, which equals 1 nautical mile. As I originally told you, oh, you can't read that very well, can you? Oh, there it goes. So I originally told you up here that 1 nautical mile is equal to the length of 1 minute of the equator. So here we go. So S equals, or we'll instead of S, we'll just say 1 nautical mile. That's really what we're finding. 1 nautical mile equals, so we're starting with our conversion. Our radius, which is 3,956 stat miles over 1 times, so this was our radius. I'm going to write that down. That's where we came up with this. So that's our radius, our R, times 1 our theta. So our theta is this conversion we came up with over here, the pi over 10,800 radians. And that is our 1 minute in radians. So if you take your handy dandy calculator, we're going to take the 3956 and we're going to multiply it to pi. So that's our numerator. And then we're going to divide it by 10,800. What do we get? 1.15. So that's where that standard conversion comes from, 1.15. So it is approximately equal to 1.15 stat miles. So 1 nautical mile equals 1.15 stat miles. That is a conversion you can use, but here's the problem. We were given 2,698 statute miles, right? Well, each of those statute miles we want to convert to nautical miles. Well, we don't have that conversion. We could take this, which is stat miles over 1, and wouldn't we multiply that if I want to get rid of stat miles by 1 nautical mile over this? Couldn't we? So that's one thing that you could do. We could also find the inverse of this. So think of it this way. If I had 12 inches equals 1 foot. Well, that would be my conversion if I needed to convert, feet to inches. But what if I need to convert inches to feet? What's 1 inch equal to? in terms of feet? 112. Aren't they inverses of each other? 12 inches to 1 foot, 1 inch to 112. Those are inverses of each other. So my point is this: if I wanted to have, 1 stat mile equals how many nautical miles, here's what we would do. We'll find the inverse. So 1 stat mile is equal to, I'm just going to take the inverse of this. I'm just going to flip this. So on the top would be my 1 times 10,800. Isn't that 10,800? Divided by, and on the bottom is going to be the 3956 times pi. So can't we put that into our calculator? So that's approximately equal to, let's see what that inverse is. So I've got 10,800 divided by, parentheses, 3956 times pi, and parentheses. Let's round that to 4 decimal places. What does that 9 round to? The 89 rounds to what? A 90. So it's approximately equal to 0.869 nautical miles. So now we have 2 conversions that we could use. Okay, are you ready? One conversion is this one here. What color is that going to give me? Aha. 1 nautical mile is equal to 1.5 stat miles, or 1 stat mile is equal to 0.869 nautical miles. Depending upon what you have, one of those is easier than the other. So when you do your homework tonight, know those conversions. Since I started out with stat miles, each one of these stat miles, 1 stat mile, each one of those stat miles, doesn't it equal 0.869 nautical miles? So couldn't I, for my final step, use that one instead? So my final step, I'm going to take my 2698 stat miles over 1, and I'm technically multiplying it by 1 stat mile in the denominator, and then 0.869 nautical miles in the numerator. So that makes my stat miles go away. And I'm really just multiplying that decimal to the 29 or 2698. Now, because everything was given to me in whole units, what's the nearest whole unit here? How many miles? 2345. So that means, therefore, we are approximately equal to 2345. What did I convert to? Nautical miles. So our last and final step is to answer the question. So step 6. Therefore, the distance from New York to Phoenix is about 2,345 nautical miles. Once you know your conversion, all you would have had to do would be step 5. Now, could you have used the 1.15 and just know that one and memorize that one? Yeah, sure. So if you know that 1 nautical mile is equal to that, then you would have instead here, you would have put the 1.15 stat miles in the bottom and 1 nautical mile up top. Doesn't that mean you would be dividing this by 1.15? Let's see if that gives us the same answer. So if I were to take the 2698 and divide it by 1.15, do we get the same answer? Why is it slightly off? This was my exact answer for the nautical miles. Was that my exact answer for the stat miles, or was that a rounded answer? That was a rounded answer. So that's why here I'm a little slightly off from there, which is fine. but I essentially got nearly equivalent, right? All right. So tonight, you're going to have about 10 word problems. I fully expect that you're going to make use of that example tool. So as you're using that example tool to kind of help you through the steps, sometimes they explain things a little funky, okay? So I can't help that. But you are creating a study guide. You must write down, and I cannot emphasize this enough to you, stop fidgeting and listen. You must write down the directions, the word problem itself, all of your work and the answer. And then what I would like you to do is highlight the steps that you don't understand. Why are they doing this? So that you can ask those specific questions. But if you don't highlight or mark that in some way, you have no ability or no reason to remember to bring that question up. And there will be times all next week that I will ask you to come in with questions. So we'll go in the math lab several times next week, but you cannot go in the math lab and start your problems there. You have to start them at home. And you have to bring me, if you have nothing in front of you, I'm going to be irritated. I'm just going to tell you that right now. Because this is a long chapter. This is only section 4.1. By the time we get to 4.8, you're going to forget which word problems you struggled with. Because you're going to try to put that away and never remember it again. So you got to create that study guide so that when it comes time to study for your test, you'll go back and go, oh, I didn't know how to do that word problem, but I'm going to go through and I've asked those questions and I'm going to try to remember, and review how that's done. You can't do that if you don't write anything down.